Alright, so it asks for, in problem number 10, what type of critical point do we have at -1? Well, that's where x equals -1, and that is a relative maximum. In problem number 11, when I graph x squared minus x squared, x to the fourth minus x squared plus 4, that's not a very good graph. It looks like this, and that critical point is an absolute minimum. Alright, so we're looking for vertical asymptotes, horizontal asymptotes, and holes in this one. So since these two things match, that's going to tell us where the hole is. So I add 3 to both sides. I get x equals 3, and that's the hole. Now for the vertical asymptote, I'm going to take this 2x plus 1 that didn't match anything on top and set it equal to 0. And I got 2x equals -1, and x equals -1/2. Now for the horizontal asymptote, I'm going to multiply these, but I'm only really worried about the first term. So x times x is x squared. 2x times x is 2x squared. And so we got 1/2. And it only works because these exponents are equal. For the next problem, we have this. And I'm going to factor the bottom to be x plus 1, x minus 1. And since nothing matches, for my vertical asymptote, I got x plus 1 equals 0, and x minus 1 equals 0. Subtract 1, add 1. So we got x equals -1 over here, and x equals +1 over here. Now, in order to get a hole, we would have needed something to match, so there is none for the hole. And for the horizontal asymptote, since we have more x's in the bottom, the horizontal asymptote is y equals 0. Alright, so for this one, I got 5x plus 4 equals 0. Subtract 4. 5x equals -4. Divide by 5. And x equals -4/5. Now, because these matched, that's the hole. The 3x minus 2 doesn't match with anything. So when I set this equal to 0 and solve, that is the vertical asymptote. Now once again, I need to figure out what's on top and what's on the bottom. So we got 20x squared plus some other stuff. And 3x times 5x is 15x squared on the bottom. So I got y equals 20 over 15 because they matched, which turns out to be 4/3. Alright, for problem number 15, we have a varies jointly, y varies jointly to the square of x and the cube of z. So if y equals 81, when x equals 3 and z equals 4, I'm going to put all of these, multiply them together. And so I got 81 equals 576k. Divide both sides by 576. And k turns out to be 9/64. So now we have y equals 9/64, x squared, z cubed. Plug in x equals 3, x equals 10, and z equals 4. and plug this all in, and we'll find out what y is. And y turns out to be exactly 900. In the next one, we have y varies directly to the square root of x. And so negative 9 equals k times the square root of 121. So negative 9 equals k times 11. So we can't really reduce 9 over 11. So we leave that as k. So y equals negative 9 over 11 square root of x. This time they give me y as negative 108. So we're going to divide both sides by negative 9 over 11. Making sure that we plug that in parentheses. And that gives me 132 equals the square root of x. To get rid of the square root, we're going to square both sides. And that turns out to be, x turns out to be 174.24. Alright, finally problem number 17. Y varies inversely to x squared. So if y equals 12 and x equals 4, we got 12 equals k over 16. And I multiply both sides by 16. So 192 equals k. So y equals 192 over x squared. We know y equals 152. So I'm going to multiply both sides by x squared. So 152x squared equals 192. Divide by 152. And that gives me x squared equals 24 over 19. And when I square root, I get x equals plus or minus 1.12. That's it for the second part of the review.